Yes, good afternoon, everyone. We are right away meeting again as we met the other days, and today we are meeting in a special way. My name is Emmanuel Rowe, I'm a teacher of physics, as you know. Some of you know me, some of you do not know me as we are meeting just online, and we have not been interacting previously. But as we are saying, so we want to share today. And what we're going to share up today is what we call the resultant force. I have already written something here, and I'm saying the resultant force is a single force that has the same effect as all forces acting on one unit combined. That single force. That single force that has the same effect as all forces acting on one unit combined. Even though it's 1, 2, 3, 4, 5. That single force is what we call the resultant force. So they say, find the resultant force of the following bodies. We have the body in normal one, which is here, with 2 forces acting on it. Then this one with 2 forces acting on it. This one has 2 forces, and this one has 3. But this kind is what we call forces acting in the same direction. What is the concept of forces acting in the same direction? What we are going to see and understand is that when forces are acting in the same direction, they are causing an effect in the same direction. So what is the magnitude of the resultant? The magnitude will be the summation of those forces, as we're going to see. So Roman 1, we shall have resultant force. Now, to the total of the 2 forces, 120 plus 250. So that's what makes 50, and the bracket is 7, there are 6 meters, a total of 370. So, the resultant force is 370. Then for part 2, we are having 3 forces, but they are all acting in the same direction. That means they want to remove the other side that's in the same direction. So for part 2, resultant force, that single force, is going to be equal to 3 newtons plus 6 newtons plus 7 newtons. Hence, this is 9 plus 7 plus 16. So those are in the same direction we add. Now, what about when we have those in the different directions? And that's what we're going to check out here. So we are continuing up with what we had started. Now we are looking at as we say, different directions or opposite directions. Forces acting on an object, but when they are acting in different directions, one is pulling, taking to the other direction, and another one is also pulling, taking to another direction. So those forces, we say they are acting in the opposite direction to an object. But guess what? The body will move towards the force with a bigger magnitude. How do you get the resultant? In this case, for you to get the resultant force, since they are moving in different directions, we do what we call the servo traction, as we are going to see. So, a body is acted upon by a force of 900 newtons towards this direction, and then with another of 250 newtons in the other direction. So, the resultant force will be equal to the bigger force, which is 900 newtons minus 250 newtons. So what we get? Shall get 650 newtons as our resultant. And the body will move towards the 900 newton force. Now this one is also another example, but it has a combination of 2 forces acting in the same direction and even some other 2 forces acting in the same direction. Now, how do you find the resultant? You first get the resultant of the same direction. You get the resultant of the same direction. After getting the resultant of the same direction, then you do what we call differential direction. Now check. So it is now going to be, you can say this is left hand side, left hand side. Left hand side will be our F, will be 34 newtons plus 24 newtons. Giving us what? Guess what? 4 and 4 is 8, then the other one gives us 58 newtons. Right hand side will give us, we get 7 plus 92. Okay, so we said 2 and 7 is a 9. Then 9 and 7 is a 16. So we get 169 newtons. So overall will be this, the left hand side minus the other one. So 169 newtons minus 58 newtons. Those with calculator, you can please press up, but as we check, we shall have 69 minus 58. We get 111 newtons. So that's it. That's what you do. That is the result. Now, forces acting at an angle to each other is also a different case. But guess what? What we do here is to get what we call the resultant. But as we get the resultant, forces acting at an angle, we treat them with a formula called formulas, right? By saying a squared plus b squared equals to c squared. Now, when you complete the triangle, we shall have a triangle completed where we have 8 newtons, we have 6 newtons, and then this one is going to be our force resultant, which will be our A, B, and then a C, like that. So 8 squared plus 6 squared equaling F R squared. Or as 64 plus 36 equals F R squared. 100 equals F R squared by this. So this gives us a 10. I'm going down to force resultant. So therefore the force resultant is 10 newtons. That one is getting the resultant. Now we check out this. I think this one you can try out on your own, but guess what? When you are dealing with it, you're supposed to know that the others which are acting in the opposite direction and the others which are acting in we don't have others of the same direction. They are acting in different directions but at different positions. Like those ones are going vertical and others are going horizontal. Let's find out. So here we check out for what we call horizontal component. Horizontal component, which we shall have different direction, we shall have 12 newtons minus 7 newtons, giving us a 5 newtons. And then we check out for this, which we shall have as 14. This is vertical component. 14 minus a 2, which gives us what? A 12 newtons. Then we do what we call a force diagram. This one will be going there, and this one also will be going this way. So the force resultant will be here. So this will be the 5, and then this will be 12 newtons. And then we apply my formulas and we come out for it. Thank you very much. I think our next meeting will be talking about how we deal with an object with all those forces and how we come up with a resultant. But for now, we can rest our case. This concept is much important because it is applicable in all cases. Like, for example, you remember when we used to here, we used to play. There is a game
where a group of members stays the other side, and even another group of members also stays the other side. And then you start pulling, the one with the greater force will take all the others to come to the other side. That's why we see horizontally the bigger force when it moves to the side of the bigger force. Thank you.